Before the first second ticked, before the first atom formed, before there was space to expand into or time to count, there was absolutely nothing. No stars, no planets, no up or down, no before, no after. Just the absence of everything. Today, we begin the greatest story ever told, the history of everything. And it starts here, with the beginning of time itself, the Big Bang. This was not an explosion into space. There was no space yet. The Big Bang was the expansion of space itself. Before the Big Bang, there was a singularity, a point of infinite density and energy, something unimaginably small that it can't even be measured, because it has no width, no circumference, no diameter, and absolutely nothing to measure it with. This singularity erupted into existence, and in a fraction of a second, the universe exploded. It didn't explode into something, but rather into nothing. This moment was fast beyond comprehension. In less than a trillionth of a second, the universe went from smaller than an atom to larger than a galaxy. This was called cosmic inflation. The very fabric of space-time stretched, smooth, flat, and expanding faster than the speed of light. And with that, reality began to form, and with it, time. In the first moments after the Big Bang, the universe was hot beyond imagining. Temperatures reached over 18 billion degrees Fahrenheit, or 10 billion degrees Celsius. Time itself had only just begun, and there simply hadn't been enough time for any of that temperature to cool down. For the first 10 to the negative 43rd seconds, known as the Planck era, we don't know what happened. Our current physics simply breaks down completely. The Planck era was the earliest single moment after the Big Bang, lasting not just a billionth of a second, but a billionth of a billionth of a billionth, repeat billionth about 11 times, of a second. So basically, it was 0 seconds after the Big Bang. Gravity, space, and time all may have behaved differently during this era. We might never know. We've never produced an equation powerful enough to fully understand that moment. But almost instantly, the universe expanded. Wildly, violently. This was cosmic inflation, an event so fast, space itself stretched from subatomic to cosmic size in less than a second. Then came quarks and gluons, zipping through a dense soup of energy. This was known as the quark epoch, only 1 trillionth of a second after the Big Bang. Particles and antiparticles burst into existence and annihilated each other just as quickly. But somehow, matter won. For every billion antimatter particles, there were 1,000,000,001 matter particles. That one tiny imbalance is why you exist. Over the next nanoseconds, the universe cooled just enough for quarks to form protons and neutrons. By the 3-minute mark, these fused into atomic nuclei, mostly hydrogen, some helium, and lithium. This was known as Big Bang nucleosynthesis. But these nuclei had no electrons yet. The universe was still a plasma, a sea of charged particles scattering photons in every direction. However, there was still no light due to Thomson scattering, where the photon was unable to form a beam of light. For now, larger atoms simply couldn't form. Not yet. For the next 380,000 years, the universe expanded and cooled. It remained dark, but alive with energy. And then, finally, the temperature dropped low enough. Electrons found their orbits around the nuclei. Larger atoms formed, and light was free to move. This is the moment God said, "Let there be light," and there was light. The universe became transparent, and the cosmic microwave background was created. That ancient light, the cosmic microwave background, still surrounds us today. It's extremely faint, cold, invisible to our eyes. But with the right tools, we can see the universe as it looked when it was just 380,000 years old. One way to see it for yourself is to turn on the TV. That black and white static that appears when you lose signal is composed of about 1% of leftover radiation from the Big Bang. Literally, ancient light from the birth of the universe. What we see isn't stars or galaxies. Those don't exist yet. We see a soft glow spread evenly in every direction, with tiny, tiny imperfections like ripples in temperature, little pockets of denser matter. And those tiny imperfections, they are everything. They are the seeds of structure, the blueprint for everything the universe would become. Galaxies, stars, planets, even you. The universe at this stage was quiet, but not empty. Filled with hydrogen and helium gas, it continued to cool and expand in every direction. Gravity slowly began pulling matter together. Tiny fluctuations grew denser. Regions of gas began to condense under the influence of gravity, and over millions of years, these balls of gas would soon ignite into the very first stars. The first stars lived significantly shorter lives than stars today. They burned through their fuel in just a few million years, and in their deaths, they did something incredible. They changed the universe. They filled space with new elements: carbon, oxygen, nitrogen, and iron. Heavy atoms were forged in these cores and scattered throughout the universe. Now, the universe wasn't just light and hydrogen, it was full of the ingredients for complexity, for planets, and for life. Not only that, the death of early stars gave rise to a new terrifying concept: black holes. Black holes are points in space-time where the center, a singularity similar to that before the Big Bang, is so dense and full of matter that its gravitational pull prevents light from escaping. Slowly, stars began to orbit these black holes, which led to the formation of galaxies. And as galaxies grew and evolved, they became element factories, building new generations of stars with every cycle. One such galaxy, spinning gently at the edge of a cosmic web, was the Milky Way. The Milky Way wasn't created all at once, but rather built over time. Smaller galaxies collided and merged, swallowed by gravity and absorbed into a growing spiral. The Milky Way, like all galaxies, was sculpted by gravity, held together by the mysterious force that shapes the universe. Somewhere along this disk, now called the Milky Way galaxy, was a large clump of gas and matter. Specifically, this clump existed in the Orion arm of the galaxy, which on most maps is in the bottom middle part of the galaxy. Soon, this gas began to condense, until 4.567 billion years ago, or 9.2 billion years after the Big Bang, it ignited in a fusion reaction. As a result, a brand new star was born, one that, as of now, was the only star in the universe known to have a planet harboring life. That star is the Sun. And with the creation of the Sun, orbiting clouds soon formed into what we now call the solar system.